In this session, we will control the DS18X20 temperature sensor using MicroPython and Raspberry Pi Pico. First, please insert the module, and we will display this value on the OLED display. Additionally, if you look at the examples for controlling the DS18X20 in O1 Studio, they mostly show it being controlled with GPIO 27, which is incorrect. If you did it that way, you would probably encounter an error and be unable to proceed. In reality, it is connected to GPIO 16, so I will explain it again when I write the code later. You can make the connections like this. First, to control the DS18X20 this time, the interface for controlling the DS18X20 uses one-wire communication, which I mentioned before with the NRF5284 row. So, you need to add the code related to one-wire communication and the DS18X20 module. If you go to this link, you will find the code related to the one-wire module driver. Please copy it. Create a new file in the library folder named onewire.py and paste it there. Next, if you go to this link, you will find the DS18X20 driver module. Copy the source code here, create a new file, and name it DS18X20PI. Please paste it like this. The library is ready. Next, open the main file, delete this, write the code. From, machine, import, pin from, SD1306, import, SSD1306, from, one wire, import, one wire, from, 18N20, import, DS18X20 import, time, as we have consistently done with the display in our previous experiences, SDs for PNC, which stands for Programmable Network Controller, please ensure that you set the SDA or serial data line to PNC mode and configure it to the hexadecimal value of 0x30, which is crucial for proper communication. Now, regarding the temperature sensor DS18X20. There are several examples available where the one-wire instance is set to pin 16 and GPIO 27. However, it is important to note that using GPIO 27 is incorrect. In reality, the correct connection is to GPIO 16, which ensures accurate temperature readings and proper sensor functionality. When you perform a DS scan operation like this with the ROM DS10 configuration, the unique ID information of the connected one-wire devices will be captured and stored here in a structured array format. This stored ID information is crucial as it will be utilized in subsequent operations. Later, when you execute the read command within the continuous while true loop, you will be able to display the first value extracted from the stored ID information, the display text is shown on the device model, and the display text is clearly visible on the screen. To implement the desired functionality, begin by writing the code as follows. Use the display text function to present the string on the screen. Next, convert this string into a numerical value, ensuring it is precise up to the second decimal place, which is essential for accuracy. This conversion should be in Celsius, as it is the standard unit for temperature measurement in scientific contexts. Following this, employ the credit show function to display the credit information clearly. Finally, incorporate a sleep function that pauses the execution every 1 second, ensuring a smooth and controlled display of information. This methodical approach guarantees clarity and precision in the code execution. Let me check it once. The program is currently running, and in this state, when I touch the DS18X20, the temperature is gradually rising. In this way, as the temperature rises, it will slowly drop when I let go. In this way, you can measure the ambient temperature using the DS18X20 temperature sensor. This time, we used MicroPython and Raspberry Pi Pico to control the DS18X20 temperature sensor. I will see you again next time with different content.